Assalamu alaikum wa rahmatullah wa barakatuh. This is the engineering drawing course, lecture number 3. In this lecture, we will continue talking about the orthographic projections or multiviews. And today, inshallah, we will add the miter line and use it to transfer dimensions and shape from one view to another. So let us take this example. In this example, we have the multiviews, we have the front view, we have the right side view, the top view, and we want to try to draw and imagine and draw the isometric view for the part, the 3D view for that part. By the way, guys, we have to check where is the front view. Surely this is the front view. As you see, we have a view to the right and a view to the top. That means the view at the middle, it is the front view. Next step, what this view? Is it the right side view or left side view? We have to indicate this one. How we can know that? As you see from the top view here, from the top view, we can say that we can see that there is a gap on the front. So this is the gap in the front. That means this is, as we said, this is the front view. That means this is the top view. The top view. In this case, this will be the right side view, not the left side view. And this is not this is not first angle, it is a third angle projection method. So the conclusion that this is front, this is right, this is top view. Next, now how we can imagine or build the 3D shape for that object? There are many methods actually, and no one can give you algorithm or equation or a device or whatever that if you have the multi-views, it will give you the 3D view. No, it depends on your experience, previous experience on how getting the multi-views from the 3D object, and some experience of imagination. So we'll mix between our experience of projections and some imagination to try to build the 3D shape. But mainly we have two methods. We can use them. The first method, it is a forming method. That means you have to draw a 3D box like this and try to add material or remove material until you get the final shape. The second method, it is called extrude method. In the extrude method, we will take one of the views, as example, this top view, and make extrude like this. The extrude, it like giving the multi-view a third dimension or depth like this. Okay. In general, it depends on the multi-views you have and how the multi-views are complex, or the part is complex or not. So sometimes you need more than extrude, sometimes you need forming. It depends. Now let me start. Try to find the proper representation, 3D representation of the multi-views I have. By the way, this is the miter line. I will use this miter line to transfer dimensions from one view to another view. As example, these are the extension lines from the front toward the top view, and these are the extension lines from front to the right side view. And same thing, we can take extension lines from the side to the top view. So we can use the miter line. Anyway, now I will use in this case the extrude. Now, according to my experience, and again, this is one of the algorithms. One of the algorithms I will use today, I will take this area from the side view and I will make extrude. As you see, just draw this shape and extrude it in the third direction like this. and then we will try to think. Now if I will now I will try to draw the front view. From the front view I will get this surface. So I have this surface now, and this surface, it is this surface dimension, I know them, so it's okay. If we compare the current front view with this front view, as you see we have two areas, one above this line and one under this line. That means this is the line here. We should modify our object to get this gap as example. How we can get this gap? Or we can also take the side view. If we look to the side view, this area, it is this area, and we know the dimensions for this area, and then we want to fix this 3D object to get this surface. Now from our experience we know that this surface, it is something here, it should be here like this. Okay, because if this surface, if this surface and this surface and the same work plane or same plane, there will be no a line in between. That means this surface could be in the front and this one in the back, or the opposite, So let us try one of the say that one of the solutions or options. I will imagine that this surface, it is in the front here, and this one in the back, So how can I do it? As I told you, we will draw the 3D shape, and then I will try to draw a line here. I will draw this line and this line and this line and this line. Okay, so there is something here. As I told you, we have to see something like this. Okay, now this line and this line with this one and this one, it is the original view. Okay, now how can I get this surface? As we said, we have to add something or remove something. Now if we compare the front view, we have something down and something up. Let me start from the down one. From the down one, there is a rectangle. Where is this rectangle? That means to get this rectangle in the front view, I have to remove this area. So let us remove this area. So now again, we'll draw a line like this and try to cut this area from the object and remove it. If we remove it, we will get the shape of the front view. So this is the next step. Actually, it is not a cut. Now, if it is a cut, that means there is a line here, and what we have in the front view and in the side view, the original one, as you see here, there is no line here, solid line. That means we don't have a line here or cut. It should be something called join, not cut. So we have material here, as you see, we have a material here. The cut, it is behind, not in the front. Now if we look to the right side view, we got this surface correctly, no problem. Okay, and now look to the front view, we got this rectangle correctly. Okay, and now we have all of this surface. Okay, so it is correct. Now this suggestion or this option is correct. Next, now I will go back to the right side of view. We said that we will finish this one and this later this one. Now I want to find a way to get this rectangle. If we look from here, it's a space. It's a space. That means there is something here, guys. So now I will try to draw a rectangle like this and make it extrude or join material like this. Now it should be from here to here only or extended. Let us check the front view. If we check the original front view, there is a line like this and like this. That means it should be up to here only. So now I will try to draw a rectangle here and just extrude it like this. And let us see the result. Now, after doing that, we got this shape. Now, the second step or next step should be to verify that this 3D shape, it is the correct one. It could be another one, not this one. So how we can check? Now take the front view. This is the front view. I have this surface. I have this surface, this surface, this surface, and we have this line. It's a point here, and this edge, it is this one. This edge, it is this one, and this edge, it is this one, and this edge, it is this one. So the 3D shape, it is correct if we check the front view. Now let me check the side view, the original side view. As you see, this rectangle here, it is actually this line and this line and this line, this line, the L shape. Okay, and as you see, we have this surface, is a rectangle here. So that again, for the side view, it's correct. Now let me check the top view. In the top view, again, we have this rectangle. Sorry, this line, this line, this line, this line. We got this surface. This is the surface. And here we have this rectangle we got from this surface. Okay. And here also we have, by the way, we don't have a line here. We have a space behind this edge. As you see here, the space behind this edge here. So we have an edge here. It's hidden edge. This hidden edge will be a hidden line here. So we should add a hidden line here. And same idea for the side view. We have this edge, which is hidden edge, like this. Okay. Now this edge, guys, it's hidden. So we have to add a hidden line here. And this hidden line, it is under the visible line, so we should not draw anything. Now, if we compare the original multiviews with multiviews we got for this product, that means this is the correct 3D object. This is another example. In this example, we have the 3D object, and we want to draw the multiviews. How we can draw the multiviews? Let me try to show you how we got these multiviews. In general, the method, we should start from the front view, choosing the front view. Now, as you see here, it is the longest dimension, and we can see this face and this face and this face. So we should keep the top view and the right side view, because I can see it easily, and this front view. So we have to draw the front here, the right here, the top here, like this. Okay. Now, why we choose this as a front view? because as I told you, this is the longest dimension, and I can see most of features from the front view. So this is why I select this one as a front view. So again, this is the front view. Now from front view, I can see we have dimensions 1, 2, 3, 4, 5. So we have this length. We should go and draw this length. Okay. We have this line, same length. This is 2, from here to here 2. We should go to here 2. We'll go 1 to the top, up, and then go this distance from here to here, and then go down this distance, and then this line, and then close it. So we got this surface. Now all of this surface is this surface. Okay. Next, what about this surface? It is in the back, not in the back, sorry. Compared with this one, it is inside. But this line projection will be here. This line projection will be here. So we got this surface here. Next step. What about this hole? This hole, it's a through hole. And the thickness of this hole, same thickness of this part. According to the dimensions given here, we should indicate where is the center, draw the center line, and draw the circle with the given radius or diameter. In the top view, sorry, I'm talking about the front view, not the top view. In the front view, this is the location from here to here. This distance should be taken from the 3D view, and I will draw the axis here, then shift with distance equal to radius, and draw hidden lines, because this hidden cylinder, here, the view of cylinder in general from this side, it will be rectangle. If it's visible, rectangle should be solid line, thick, not thin. Now from top, it will be a circle. It's visible. If it's visible, it will be a solid thick line, not thin. If it's hidden, it will be hidden lines. So we finished this one correctly. Now what about this hidden edge from the front view? It's from here to here. We know how much this height, so we'll go from here this height, and then draw hidden line to represent the hidden edges. Now the front view done. I will take extension lines from front to the side view. If you thinking to start from right, it's okay, or from top, it's okay. I will choose to start from right. Next step. Now from the right view, I can see all of this surface. I have dimensions, so I will draw it line by line. Same dimensions here, because we are facing that surface, so that the projection lines are perpendicular. We will get the same length for each line. Then we can see this surface. We have dimensions, and then we can see this surface also. We have dimensions, and there is a line in between represent this surface. Actually, this line. What about the this hidden edge here, from here to here? This hidden edge, it will be a hidden line, so we know the height, this height from here to here. So we'll go up to here and draw a hidden line like this. And then for this hidden cylinder, again the location at the middle exactly, and we know that the thickness of this cylinder up to here, so we'll draw two hidden lines. We finished the right side view. Next step, we want to get the top view. We'll use the miter line. Say that we know the distance from here to here. We can say 2 centimeter. We can say it depends. So we'll take the same distance from here to here. Okay, that means this side should be transferred to here. This side should be transferred to here, and this is the miter line. So we can take edge by edge. As example, this edge should be to here. Now, in the top view, how can I draw the top view? In the top view, I know this line length. Starting from here, I will go up like this. And this line, we know the length from here to here. And this line is like this. This line, it is like this. Okay, and this line, it is like this. We know dimensions. And finally, this line. Okay, so we got this surface, guys. All of this surface is this surface. Okay, now this cylindrical hole, it's a visible from the top view. Again, we should draw the center and the circle. Now this edge, it's hidden edge from the top view. We have to draw it like this. And this edge, same under this edge. This line, we know the distance, and actually you should extend everything from the top view, from the front to the top view. And then this corner, as you see, this corner should be transferred to here. So I will draw the header line here. Now this line, as I told you, it is under this line also. And this line, it is this line. And this line, it is this line. Then, as you see here, this surface, it is this surface. Okay. Now, what about this hidden edge and this hidden edge from the top view? Transfer the location from the side view like this, and then you can draw the hidden lines until here, because this gap will intersect with this gap at this corner here, at the end of this corner like this. Okay, it will become like this here. So we have two hidden lines, and this is the other hidden line, and here we have a hidden line also. Now this is how we can draw the multiviews. Now the relation between the right side view and the left side view, if we look from the left here, guys, and look from the right, actually it is mirrored from each other. So the relationship between the right side view and the left side view mirror. So as you see here, the mirror line, this mirrored like this. Now, guys, mirror this one to here and try to fix the some edge, because from right view, it could be there is an edge, a visible edge, but from the left view, it will be hidden edge. As example, this edge, this corner, from left, it will be, or this one, it will be visible, but from right side view, it will be hidden. So as you see here, from right, this edge, it is hidden, while the same edge in the left, it will be visible. Now another example, this edge, or this edge from right side view will be visible, but in the left side view it will be hidden. Another example, this edge in the left, it is hidden, which is this one, while it is in the right view, it is visible. So the relationship between the right side view and the left side view, it is the mirror, but we have to check the edges. Some edges will be visible in the right, it could be hidden in the left, and so on. And the same relationship between the top and bottom view. So guys, this is the symmetry line. So the relation between them, same relation, mirror. So if you have the top view, you can get it easily. Just mirror it down to get the bottom view. This is the top view. And same idea, you have to check each edge. Now, as example, this edge and this edge and this edge and this edge, actually this corner, and this corner from bottom visible. As you see, this line and this line visible. They are both hidden from the top view. Another example, this edge, as you see, it is visible in the bottom view while it is hidden in the top view. I'm talking about this corner. This corner, when you look like this, it will be visible. From top view, it will be hidden, and so on, guys. So this is the relation between side views and top and bottom. It is a mirror relation. Take care. Next example, same idea, guys. In this example, we have to draw the multiviews. Let me start, or let me make zoom, a little bit zoom in. Okay. Now, again, this is the longest dimension, and most of feature can be seen from here. So I will select this view as a front view. In this case, I have the left can be easily seen and the top view. So I have to draw the front here and the left side view here and the top view here in the first in the third angle method. Third angle method. Okay, so this is the front view. Now I know this line and this line and this line lengths. Sorry, this line I don't know exactly how much its length. So I will choose this edge. I will start from this edge. I will go to the left, 150 minus 48. Then I will go up 36. And then I will stop here, which is here. And then I will go draw this line. We know that that distance, it is 82 minus 12. So I will go from here to here. And then I will draw a line like this, guys. I don't know where is the end of the line. Now, guys, this slanted edge projection will be a vertical line like this. And the length of this line, it is 12. So we can draw this line from here to here. It is 12. Then this edge projection will be like this. Okay. And this thickness from here to here given 32. So we can draw it from here to here, 32. Stop here. We got this point. And we know that from the side view, this line and this point, with this point, it is just like this. So this line and this line projection will be like this. So from the front view, sorry, not the side view, connect them together, we got this line. Now we can trim this line. So let me delete it and draw it again. We will get this line, which is from here to here. Next step, this surface, it will be from here to here to here. This hidden hole or slot, we have a surface limit here, guys. It's a hidden line like this, and this is the axis of that semi cylinder, and this hole given diameter, but the depth not given. That means it is through hole. So we have two hidden lines here. Okay, so the front view finished. Now we got the front view. How we can draw the left side view from here? This one. Again, from the center, we'll go and draw this line, then this line, and same this line, and the back one here. Okay, and as you know, we have a circle here, so the edge of the circle, semicircle, will be like this one, visible. It is inside this gap, but it is visible. Now this height, by the way, guys, this is the question says that we have to draw first angle method. Okay, in the first angle method, again, we said that this is the front view. We know we need the front view, the left side view, and the top view. In the third angle method, the front view will be here, top at the top, and the left at the left. To make it first angle, the left will be on the right, the top will be in the bottom. So for the first angle method, we got the front like this, the top like this, and the left like this. So this is our target. Okay, in this case, we will draw these lines here, because I'm drawing the left and the right side. Now this surface, and then this surface, and the back one like this. And now we should go from, I will draw this line, because this point exactly it is here. So we know the height, it is 82. Stop here, and we have same edge from this side, so 82 also, and stop like this. From the center, we know this distance should go like this to draw this one, and the other one like this. So total 22, 22. Sorry, 12 plus 12, which is 24. Now we know this line, edge, and this edge. Just connect this point and this point. Just connect them to get this shape. That means this slanted edge, it is this one, and this one, it is this one. The projection. And the projection of this line, actually, it is here, and the projection of this line, it is here. And the hidden edge, for this hidden edge, it is from here, this surface, to this surface. But on this location and this location, we have it under the visible line, so we'll see just the upper side as hidden line. So we'll get it like this. Now we can draw top view. Should draw top view in this location, guys. We can see all of this surface, so we have dimensions we can draw. Now I will draw this line from here to here. and stop. Draw this line and the back one in the left in the back, yes. And we have this edge, or this edge give you this line. Now from here to here we should go 12. Go from here to here 12 and draw this line which is 15 and stop. And same thing this line, and then all of this line actually projection will be like this. So the projection of this line, it will be this line. So we'll connect like this, guys. Okay, how we will know exactly where is this point and this point? We'll take it from the front view, and then we have this edge, this is the edge, this circle, this circle. Now the top view done. Just to remind you, this is the front view, this is the left, and this is the top. If we want to get the bottom, mirror from the top, the right, mirror from the left, and we have to edit or modify some edges, because maybe one of the edges from right will be visible and left will be hidden, and same thing between the top and bottom view.